Today, we're going to dive into one of the most profound, honestly, one of the most mind-bending ideas in all of modern physics. It's called the recovery rule. And trust me, it's a concept that's going to completely flip how you think about information, reality, and maybe even the past itself. All right, first, let me just ask you a simple question. You take a book, right? You set it on fire, it turns into nothing but ash and smoke. Is that story, all the information that was inside, is it gone forever? I mean, your gut reaction is, of course it is. But what if I told you that the universe, on a fundamental level, completely and totally disagrees? See, this is where things get really weird. Our everyday experience is in direct conflict with the bizarre rules of quantum reality. We think we can just copy-paste a file a million times. We think that if you burn a library, that knowledge is gone for good. But physics tells us something else entirely. It says you can never make a perfect copy of information, and at the same time, you can never truly destroy it. So how can both of those things possibly be true? Well, that sets up this huge cosmic contradiction, right? How can information be impossible to copy and impossible to destroy? It turns out that solving this very puzzle reveals something incredibly deep about the structure of spacetime itself. So let's get into it. Let's unpack the two big shocks that led physicists down this rabbit hole. The first major clue in our cosmic detective story dropped back in 1982, and it completely blew up one of the most basic assumptions we have, especially in the digital age, the simple idea of making a perfect backup. Right, it's called the no-cloning theorem, and here's the part you really need to get. This isn't about our technology just not being good enough yet. No. This is a hard-coded rule in the operating system of the universe. The laws of quantum mechanics literally forbid you from creating a perfect, independent copy of an unknown quantum state. It just can't be done, period. And that, right there, creates a huge problem, doesn't it? I mean, think about it. If you can't make backups, how in the world can you protect information from getting lost or corrupted? All of our computers, our entire digital world, is built on making copies for redundancy. This theorem seems to suggest a robust universe should be impossible. But okay, just as physicists were trying to wrap their heads around that bombshell, a second shock came from the complete opposite direction. It all started with Stephen Hawking's incredible work on black holes, and it led to maybe the biggest paradox in the history of science. Okay, let's just walk through this for a second. Imagine you drop that same book into a black hole. That's step one. Now, over billions and billions of years, that black hole is going to slowly evaporate by leaking something called Hawking radiation. Step two. But here's the kicker. Step three is that Hawking's original math showed this radiation was completely random, just thermal noise, like static. And this created the paradox. If the information only comes out as random static, then the story in the book is gone forever. And that breaks one of the most sacred rules in all of physics, a rule called unitarity, which says information can never, ever be destroyed. So physics was totally stuck between a rock and a hard place. You can't copy information, but you also can't destroy it. The breakthrough, the solution, came from a completely different field, information theory, and it was pioneered by an absolute genius named Claude Shannon. So picture this. It's 1948. Shannon is trying to solve a really practical problem, how to send clear messages over noisy old telephone lines. And his brilliant insight was that you don't fight the noise by trying to make a perfect silent channel. You beat the noise by being clever with how you send the message. And the key was one word: redundancy. And this little table is just a perfect way to see how it works. It's so simple, but it's genius. Instead of sending just a 0, you send 000. Now, let's say some noise on the line flips one of those bits, and what your friend gets is 010. Well, they can still make a really good guess that the original message was 0, just by taking a majority vote. You've corrected the error without ever needing a perfect copy, just a redundant code. And believe it or not, this simple idea from a telephone problem, this is exactly how the universe itself operates. It doesn't protect information by making perfect copies. It protects it by encoding it redundantly all across the fabric of spacetime. This is the whole foundation for the mathematics of recovery. So here's the big takeaway. The universe is basically a giant quantum error correcting code. The information about any single particle isn't just sitting in one spot. Oh no, it's spread out, it's entangled with everything around it in a way that protects it from being completely erased. Okay, so how does it do that? Well, the physical trick it uses is a concept called screening. Just imagine you've got 3 regions of space, A, B, and C, with B sitting right in the middle.
If B screens A from C, it just means that B holds all the connecting information between them. So once you know everything there is to know about that middle region B, looking at the outside region C tells you nothing new about A. B has all the info.
To make this feel a bit more real, just think about your own body. Your skin, it's basically a screen, or what physicists sometimes call a Markov blanket. Everything the outside world can possibly know about your internal organs has to go through your skin. It captures all the relevant connections. And look, this isn't just a nice story or a cool metaphor. There's a hardcore mathematical proof for this. It's an actual recipe called the PETS recovery map. And what it shows is that if one region screens another, you can use the information in that screen to perfectly reconstruct information that seems to be lost. Redundancy implies reconstruction.
All right, so now we're armed with this incredibly powerful idea of recovery through encoding. Let's go back to the scene of the crime, that black hole paradox. How does any of this solve the problem of Hawking's supposedly random radiation?
Well, the answer lies right here, in something called the Page curve. At first, as the black hole starts spitting out radiation, the information seems totally random, and so entropy, which is just a measure of disorder, goes up. But then, right around the halfway point, something amazing happens. The early radiation that's already out there has become a big enough screen that it contains enough redundant information to start rebuilding what fell in. So the entropy actually starts to decrease because the late radiation is connected to the early radiation.
So there it is, the solution. The book's information was never destroyed at all. The black hole just acts like a cosmic shredder and encryptor. It scrambles all the information up and encodes it in these super subtle connections within the Hawking radiation. It's not lost. It's just really, really well hidden.
And this is where we get to the final and, frankly, the most mind-blowing part of this whole story. Because if information can never be truly destroyed, only scrambled and encoded, what does that mean for everything that has ever happened?
What it really means is that the past, it's never really gone. The information from the Library of Alexandria isn't destroyed. It's just scrambled into the light and the heat and the smoke particles that spread out across the universe. In principle, all of that information is still out there, encoded in the cosmos. It's encrypted with a key that's impossibly complex for us to ever find, but it's not deleted.
Now, before you write all of this off as some kind of wild sci-fi theory, you need to know this stuff is being tested, and it's holding up. That core principle of unitarity, that information is preserved, it passes every single test we can throw at it. The math that predicted information gets out of black holes, that was confirmed with new calculations in 2019. And the quantum error correction that makes it all work, we're actually doing that in labs right now. This is real, testable science. Which brings us to one last, absolutely staggering thought to leave you with. The universe seems to be a perfect recording device, a device that never, ever deletes a thing. So if every single bit of information is permanently encoded into the very fabric of reality, what does that say about every moment you've ever lived?